students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NEET graduate. So bring out your books. Let's make your preparation stress-free. So our next question is, electrostatic field line can never form a closed loop. This is due to which of this following option? So our correct option is conservative nature of a electrostatic field. Why conservative nature of electrostatic field? Let's try to understand this. So as we know, this electrostatic force, this electrostatic field is generated from electrostatic force, which is also known as Coulomb force. So Coulomb force is a conservative force. Coulomb's force is a conservative force. And conservative force is something whose work done independent of path. Independent of path. So if work done is independent of path, means it is only depending upon the initial position and the final position. So for a closed loop, now for a closed loop, initial position and final position will be same. Initial position, final position will be same. So for a conservative force like a Coulomb force or electrostatic force, the work done for a closed loop, should be equals to 0, correct? So this is that should be our work done for a conservative force. Now, since it is an electrostatic field, let's see if this is an electrostatic field, and if you release a charge q in this field from here, so this is a charge q, and I have released this charge from rest in this electrostatic field, what will happen? It will start moving in this direction. The force will be along the field, and displacement due to that force will also be along the same direction, along the force, right? So similarly, if electrostatic field is like this, and if you release a charge q here, the force will be along the electric field and displacement will also be there. So now in a closed loop where electrostatic field will be like this, always along the tangent. So force, if I am releasing a charge q from here, the force will be along this, and displacement will also be along some small displacement. Let's take dx, will be along this. So if we'll add this small dx, for every dx the force and displacement will have a 0 degree angle between them. So work done formula, as we know, is F dot S, force dot displacement. So magnitude of force, magnitude of displacement, and cos of angle between them, correct? Cos of angle between them. So there is a force. If there is a charge in an electric field, it will experience a force. That means force is non-zero. If there is a force on the charge released from the rest, it will displace some distance. So displacement is non-zero. So only thing that can be 0 is cos theta. So in the electrostatic field, we saw that angle between force and displacement will always be 0. If force is in this direction, the particle or the charge will also displace in the same direction. So if angle between force and displacement is 0, that means cos 0 will be 1. That means work done for a closed loop should not be equals to 0. Since see, they both are contradicting each other. So if we are forming a closed loop with the electrostatic field, the work done should not be equals to 0, but according to this conservative nature, the work done should be 0. So since they both can't satisfy together, that's why the electrostatic field will never form a closed loop. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.